Welcome everyone to this week's IPLD dev meeting. It's August the 10th, 2020. And as every week, we go over the stuff that we've worked on in the past week and will work on in the next week, and then discuss open agenda items we might have. And this time I even have a general section before I start with the weekly updates, because it's kind of like also outside people were involved. So therefore it's like not really like on someone's plate. Perhaps later on someone put it on his plate, I don't know. But it's important because there is a change in CID. It's not a breaking change, it's just a change of the definition, what a CID is. Yes. So we don't have a version number for CID anymore, but the version number is actually also a multi-codec. So this means that CID version 1, which is hex code X1, is now a proper multi-codec. And in the future, we will also use multi-codec. So in theory, CID version 2 might not even be having the byte value 2, but could be byte value whatever multi-codec supports. We have already reserved version 2 and 3 in the multi-codec table because it just makes sense to have those numbers. But in theory, it could be something else. And we could even decide, that's like kind of was discussed, but I'm not sure if it's a good idea, that CID version 0 is defined as the same multi-codec as SHA-2, because that's what it actually is. So that the definition, we could change the definition of what a CID version 0 is and say the first byte is actually the multi-codec, and then it contains the hash without a hash identifier. In theory, we could do, but we probably won't. But that's just, yeah. So anyway, if anyone who's watching this is using CID, nothing really changes for you. It's just a matter of, having it defined in a different way, but it's not really, breaking anything. Cool. Then I go on with myself. So in the Rust multi-hash world, I've added a few docs to the tiny multi-hash library, which should go upstream, and this was merged. And I've also opened an issue about on tiny multi-hash, which things I would want to get fixed before I want to upstream it to proper Rust multi-hash. I haven't had that much time last week to work on it. Hopefully this week I will have more time. On the JS IPLD side, the changes that we use uint8 arrays instead of node buffers bubbled up. So it's now also in JS IPLD and the stacks below, like multi-formats and so on. But this work was basically done by Aching Brain. I just did reviews and pieces of the stuff, but he did the hard work of doing actually the code changes. And the only things that I kind of left is JS IPLD Bitcoin and JS IPLD Ethereum, which are internally still using buffers. So we convert the stuff on the way in and on the way out to make it work. But ideally, we would change this. But it should be possible with Bitcoin, with Rod's new library that he did, probably. For Ethereum, this will be, at one point, if someone creates a proper JS Ethereum library that we might want to use, which also Rod might do in the far distant future. But I hope so. So, but that's like not anything blocking or something. It's just, if you want to get rid of the full Node.js buffers in the full stack, we would need to also update those, except if we don't bundle them, then it's fine, because if you don't bundle them, you don't have the dependency. Okay, and that's all I have. Next on my list is Peter.
Yes, again, another underwhelming update. I'm mostly still doing Filecoin things. For those who wonder, like, what's he testing that much when we have the entire Filecoin Oni team What I'm focusing on is doing things on the live chain with all the extra nastiness that comes from, having more people on the chain and having fluctuations in how your messages are taken one minute and the next minute nothing goes on chain at all and things like that. And this unfortunately takes an extraordinary amount of time. And discovering things in between, misconceptions between like the implementation team and the CE team and so on and so forth. So a lot of time goes there. One thing that I'm kind of looking at on the side, after a conversation way back with Michael, I started looking a little bit more into a WASM target for the chunker work that I did several months ago. I am for now not giving up on Go just yet. I'm looking at what would it take to get TinyGo to actually produce WASM for me. And I know that some folks already looked into that, I think from the DRAN project, and it was kind of deemed like, there are like instabilities here and there, like some things are missing. Yeah, right. Well, actually, it was you. I forgot. And my thing is a little bit simpler, so I hope that in another 2, 3, 4 days, I can raise enough issues and enough of them can get fixed so things can get compiled. And TinyGo has a really small output. Like we're talking 2 orders of magnitude smaller than what normal Go produces. The reason I'm still focusing on Go for a little bit until I completely give up is because the Rust story on multi-threading it's workable, but it's nothing like the Go multi-threading story. And while this is not interesting for WASM itself, it's interesting for having essentially one code base that you can both push into WASM and keep it in Go, whereas a Go one can saturate as many CPUs as you can throw at it, whereas the WASM one will be, will be essentially just for a browser. And doing that in Rust on the high end of basically pushing as much of the CPU to do things with unmarshaled shared memory is doable, but it's a lot of work. It's nothing like in Go. So that's why my thinking is to try to go as far as I can with Go, and if it doesn't work, then we'll switch some parts to Rust. And that's
threading as a whole in WASM is really experimental. Yeah.
Oh, yeah. Threading in WASM is entirely experimental. I'm more like, if I switch the parts that run on a regular console, like on a regular CPU, not in WASM, to Rust, doing the multi-threading there in a regular compilation is just, you can do it, but because you essentially have POSIX threads or you have like, Tokyo and stuff like that, it's nowhere near as low overhead as what Go gives you for when you need exactly the thing that I need for basically moving bytes around.
I guess I can say from DRAN's perspective, there were just a couple like library things that on the initial attempt at TinyGo failed, and we didn't spend much time looking into it. I suspect with not too much effort, we could have gotten a TinyGo compilation target, but it wasn't. It was a web demo that we were aiming for, so we really didn't need it.
Okay. Next on my list is Rod.
Okay, I've had my head in Go all week, looking at the Filecoin HAMT, doing a bunch of work to. Well, I got the docs merged, the ones I wrote, so that's all merged. So actually, the Go doc now should be up and. Into the notes. So that's good. That was a big chunk of work, but that was from like 2 weeks ago. Yeah, okay. And docs are there in Go doc. So there's just a bunch of to-dos that came out of that. Concerns about the code and some suggestions for changes. So one of them was the collapse algorithm that keeps the hamp in the right shape when you delete elements. So the idea is that the hamp should only have one form for any given set of data. So when you delete, it needs to wind back into the right shape. And the collapse algorithm didn't look right at all to me. It's like, this looks both incomplete, but also a little bit wrong. And after pushing it a lot with like different, forcing it into different situations, it seemed to be working just fine. So it's just written in a way that was not how I conceptualize the algorithm in my head. And I think part of that is Go, and just the way that it's written as well. So so I cleaned up the code anyway and put some extra things in there to make it much more explicit what's happening. And so there's a pull request for that in the Go IPLD, Go HAMP IPLD repo. And I cleaned up the, and there's added some extra tests for that as well, for the collapse stuff. Then what I spent most of my time on was this block load time validation work. So the HAMP is really loose about what it accepts, and it's sort of just, it'll try and parse a block and then try and navigate it and just sort of fail when it absolutely can't. So I've made it much more strict now about when it loads a block, that it'll check, does this block match my expectations of what a block should look like? And so it's the kind of thing we would do in schemas. If we had all that stuff ready, like we might be able to assert a lot of the stuff I did. But this involved doing a lot of, generating a lot of manual CBOR to force it to, in the tests, to force it to fail validation on a bunch of different shapes. So there's a link there to pull request with all that work. I'm happy with that, but it's pretty strict now. It's not going to accept anything that doesn't smell right. Oh yeah, and then so the next things that are coming up, I think, now that I've done some work around the CBOR format, so validating that it accepts just the right thing. There's a couple of things now that will change the format. And so I've got some tests in now that have the format explicitly hard-coded. Now I'm going to change the format, and I'll be able to do that with the test and say, no, these things need to change from arrays to maps, or whatever it is that I'm doing. So there's two things. One of them is the bit field in this HAMP is quite Go specific in that it uses a big int, and it just takes the bytes from that, which means that, so the idea is you have this byte array and you set bits on and off in the byte array to indicate which elements of the array that you have. And the Go implementation of big int will give you bytes to represent the integer that you've created that is only as small as it needs to be and is in big endian. And so you end up with different size bitmaps in the serialization format depending on which bits are set. And there's not necessarily a bias towards smaller either. It's sort of, it doesn't actually save you a ton, but it just gives you inconsistency. So I've got agreement amongst most of the people that are concerned with this, that we should just make it a fixed width, and then we can validate the width of it against the number of elements in the array against a couple of other things. So there's extra validation there. And there's also an opportunity to consider maybe changing it to little endian. I'll look at that further and see what we ended up with the JavaScript side and a couple of other places. I think the Pyrgos HAMP as well uses little endian, so I think there's more standardization around little endian, and it's easier to mess with some of the bits when you've got little endian, just because we've got more tools for that. So maybe we'll do that. But anyway, that's one thing, and the other thing is we're going to change a keyed union to a kinded union, so that we ditch a map and a string key, and just end up with the element itself. So that'll save bytes on the other end. So those two format changes will make it breaking, but we'll bring it a lot closer to what we have in our HAMP spec. So there's a lot of room here to pull this in alignment, which is what we tried to do last year, but now we're getting to do. And then we have potential to read and write this with our other libraries that we're building for AMPs. So that's all positive. And along the way, I added a diagnostic format printed to my Seaboard encoder parser, which was really fun. So being able to stick in Seaboard and print out a really nice diagnostic format was very satisfying. And that's my week.
Next is Eric.
Yeah, so I also spent some time doing Hampty things, adding some benchmarks for the same libraries that Rod is looking at and just trying to get like a gross statistical understanding of what's going on in them. And that's interesting. We're trying to understand some of how the caching works there, and I don't know, just get more graphs out of the performance stuff. There's a little bit of work like that so far, but not a ton. And so we're just expanding. In CodeGen news, I always have a little bit, and kinded unions are now supported in the Go CodeGen, which is kind of cool. If we do a total review of like all of the completed features in CodeGen now, we've got maps, we've got lists, we've got unions, now the keyed and the kinded ones alike. We already had structs as map, and we got structs as tuple last week, and we have had structs as string join for a while. Of course, we've got all the scalars, the string bytes, ins, floats, lists, spools, links. Yeah, this is a lot of things. So there are still a couple more features for which CodeGen can be implemented, but like we're really getting down to the esoterra and all of the like rarely used representation modes. Those are the things that are left now. So I'm starting to be able to use this in alpha ways, and this is still generating more tests and fixes, but it is, I would call it alpha usable now. I'm starting to grind things out and then see if I can wire them up, and the answer is like, yeah, actually I can. So if anybody wants to play with alpha things, then I would say it is beginning to be about that time. And that's about it. I'll keep that status report short.
Thanks. Next is Michael.
Yeah, let me pull up the list here. Oh, come on. Too many things. Okay. All right. Yeah, so I did figure out how to store IPLD blocks in Git LFS. So I wrote a little storage backend for that, and I wrote a feature for DagDB to test it out, and it's pretty rad. You can even create a database and give it with a GitHub action as the type of database, and then it will pull all the credentials in the current environment from a GitHub action and use that as its storage mechanism. It's pretty awesome. LFS is like one of the worst pieces of technology I've ever had to reverse engineer, but so it's very slow, but it is like kind of amazing because it's just, you know, GitHub repos and everything. It's really nice, and it's not really noisy in the GitHub repo because it's LFS. Realized trying to finish up that work that I really don't like the tooling that we have right now for trying to build things from our ESM libraries. And so I sat down over the weekend to try and really build out the IP.js build tool. Basically, I just want a workflow where like we write a very simple ESM file, or sorry, we write ESM modules in JavaScript, and then we just have a couple named exports that point at whatever things in source or whatever, like the thing that Volker's wanted forever, where we don't have all these files in the root. And then this will generate the right common JS and ESM and the new package JSON and everything you would need to publish that as a universal module that would just work everywhere. So that is like 80% done now. I think the thing that really tripped me up was I was overthinking it. You don't actually need a compiler for most of the stuff. You can just manipulate the AST and it's much faster. So even the AST parsing and manipulation I put into workers, so it's an incredibly fast build tool as well. So that should be done pretty soon. And yeah, that'll really help us with publishing like all of our modules now and all the modules in the new JS multi-formats and block stack. So yeah, that's going. Fix some bugs in JS multi-formats, and I got the tests running again because they had broken because of that Polendina bug in Mocha 8. And I wrote some more docs for IPLD and for DagDB. And that's what I did last week. Any questions?
Thanks. And of course, like it's always like the last 20% are the easiest ones in software projects.
No. I think the last 20% here is easy. It's the 2% over that of like the bugs that we'll find later that are gonna be hard. But yeah. I think the finishing of this is actually not that much work.
Cool. Because I was wondering if anyone is bringing it up, but we also had we're discussing about the whole like JS CID stuff. Should I give an update? Does anyone else want to give an update on the perhaps Michael, would be good if you talk about because we basically talked about the transition plan to JS multi-formats. Can you give?
Right. So basically, I think where we landed is that all of the changes that we want to make for JS multi-formats are going to be accessible in JS CID pretty soon. And all of the old methods will print warnings, but they'll still work. And so that'll be like a nice transition path for people. There was one kind of final sticking point where I think a lot of you dropped off, and I think we ended up just not doing that. So I actually backed this out. We had taken a PR in JS multi-formats to make it look like an array buffer view. So it had like a .buffer property that was a Unit8 array and not a Node.js buffer. And that conflicted with the old property that was a Node.js buffer, but it still kind of worked if it was the right thing. But the issue with that is that because it's potentially a view, then that buffer could be much larger than the actual CID. And so it's this silent bad behavior that crept in. And so I actually pulled that out, and now there is no buffer property, and it will like throw if you try to access it or write it to things. And that's what we'll ship with for a while in JS multi-formats. And then we'll kind of look at the landscape after all these changes have landed in JS CIDs and decide if we want to add it back or not. And that's kind of where all of that is. But yeah, we have a much better transition plan than we used to have, essentially, is the net.
I actually checked today, I think, that array buffers don't have a buffer property. Typed arrays have. No, typed arrays have, but array buffers not.
Array buffer view. It's called an array buffer view.
And those have a buffer property because array buffers don't. Okay.
Yeah, I know. Because the array buffer. Sorry. I actually said that. Sorry. I said that wrong. The buffer property that we added was not a Unit8 array. It was an array buffer. Array buffers don't have a buffer property because they are the buffer property. An array buffer is a literal slice of memory, and a Unit8 array is a view. And a Unit8 array and everything else that is like an array buffer view is like considered a view of that. And that includes data view has the same properties as well. Okay.
So basically it's imprecise. If we talk about array buffers, you should talk about array buffer views, probably.
So this is so fucking just and just like the fucking awful standards. So you probably are talking about typed arrays because typed arrays all have the same methods. So that's Uint8 array, Uint16 array, int array, like, like all of the different view types. Array buffer view refers to those as well as data view. And data view is like a view of an array buffer that you can then do operations for every kind of typed array on. So there's just like, it's like another thing because we didn't have enough things that were binary types in JavaScript. We had to have like another one. So that's, yeah. So an array buffer view is like the standard for all of those, and it was trying to conform to that. Yeah. You're muted.
I'm looking for the window. Okay. Cool. Yeah. Anything else? Cool. I guess then we close this meeting in under half an hour. That's great.
Rod, do you want to meet right after this real quick?
So goodbye, everyone. I stopped the live stream and the recording. Bye.
I'm